Here we're going to talk about parabolas and circles in a parallel way. First, we'll consider the basic equation of a parabola. This is a particular parabola. Y equals x squared is the equation. We're going to graph this, which means we're going to find solutions of that equation and plot those solutions on the coordinate plane. So we will take x being -3. We see that y is 9. When x is -2, y is -2 squared, which is 4. When x is -1, y is -1 squared, which is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. Notice that, for example, -2 squared is the same thing as 2 squared, and therefore there is a symmetry in the picture to the right. So in the right, we'll plot, for instance, -2, 4, +2, 4, -1, 1, +1, 1, and 0, 0. 0, 0 is a turning point in the graph, and it is called the vertex. In this case, the vertex is at 0, 0. There is a geometric description of the parabola, but we won't treat it here. We will just concern ourselves with an equation for the parabola. Okay, now let's look at the circle of radius r. The circle of radius r is the set of points a distance r from the center. We're going to center our basic circle at 0, 0 and look at a point xy on the circle, any point on the circle. So we know that it's a distance r from the center of the circle. So we construct this triangle that's in red. The length of the base of the triangle is x, because that's the x-coordinate of that point. And the height of the triangle is y, so that is because that is the y-coordinate of that point. And then we can use the Pythagorean theorem, which tells us the relationship between legs of a right triangle and the hypotenuse. In this case, it's x squared plus y squared equals r squared. And this is the equation of the circle we're looking for. This is the relationship between x and y if it lies on the circle. I'm going to make a note here because we'll need it later, that the distance between x1, y1 and x2, y2, where those are any 2 points, we can do the same thing. We construct this triangle and note that the base has the difference of the x-coordinates as its length, and the height of the triangle has the difference of its y-coordinates as its length. And so we use the Pythagorean theorem and arrive at that equation. And when we take the square root, we get a formula for d. Sometimes we'll use a formula for the distance squared, and sometimes we'll use a formula for d itself. So to summarize, we have a particular parabola and a circle on our graph, and we have the corresponding equations. Y equals x squared and x squared plus y squared equals r squared. Okay, now we're going to use this as a springboard and look at transformations of the figures, the parabola and the circle, along with the corresponding transformations of their equations. So consider the equation given by this. The difference between that and the original equation is we have just subtracted 2 from x. 2, 0 is the vertex of the new parabola. We can check this by using a T-chart. I'm going to pick convenient points. So when we plug in 0, we get -2 squared, which is 4. When we plug in 1, we get -1 squared, which is 1. When we plug in 2, we get 0. When we plug in 3, we get 1. When we plug in 4, we get 2 squared, which is 4. Notice that the axis of symmetry is now x equals 2 instead of x equals 0. The vertex now is at 2, 0. Note when we plug in the vertex in the original parabola, we get 0 equals 0. When we plug in the vertex of the new parabola, we also get 0 equals 0. What does the graph of this look like? Y equals x plus 2 squared. What's the vertex? You might try a T-chart, but you should choose your x's carefully. Or you could think of what makes this equation 0 equals 0, and that will help you find the vertex. Now let's consider the circle. This is an analogous situation. So 0, 0 was the center of this equation, x squared plus y squared equals r squared. Notice that the left-hand side, when you plug in 0, 0, is 0 squared plus 0 squared, which is 0. And the center of this, however, is 2, 0. You can think of that as a difference of x's, as in the distance formula, to discover that the center is 2, 0. If we plug in 2, 0 into this equation, x minus 2 squared plus y squared equals r squared, on the left-hand side we get 0 squared plus 0 squared. The same thing we got in the standard case. What is the graph of x squared plus y squared equals 25? What's the center? What's the radius? To find the radius, you just need to compare the right-hand side of this equation with the right-hand side of this one. Okay, the next example is subtracting a number from y. In this case, we're going to subtract 1 from y for the example. Now, the vertex for the parabola is what makes this equation 0 equals 0. In this case, it is 0 for x and 1 for y, so the vertex is 0, 1. The center of the circle is what makes the left-hand side 0, which is 0, 1. So the center is 0, 1, and the radius is still r for this example. So I've plotted it there. That's a shift of the standard circle up 1 unit. In the parabola, it's a shift of the parabola up 1 unit. So in both cases, you're shifting the graph up 1 unit. Try this similar problems. One for the parabola, one for the circle. Identify the vertex and the center and the radius. Okay, now let's combine those two. Graph these two equations. The left-hand side, we note that 0 equals 0 happens when x is -1 and y is 2. So we shift the parabola over so the vertex is at -1, 2. So we shift it to the left 1 and up 2. Here the center is what makes the left-hand side of this 0. So that happens when x is -1 and y is 2. What is the radius? We'll compare r squared with 2, taking the square root, noting that r is positive. We get r as the square root of 2. So when we graph this, we shift the center of the standard circle, which was at 0, 0, over to the left one and up 2, so that the center is now at -1, 2. We can identify 4 points of the circle. This point is what you get when you add the radius to the x-coordinate of the center. This is when you subtract the radius from the x-coordinate of the center. This point is where you add the radius to the y-coordinate. This point is where we subtract the radius from the y-coordinate. And then you try to use those 4 guiding points to draw a sketch of the circle. Don't worry if your circle's not perfect. Okay, so here we're looking at 2y equals x squared. And I'm just going to first note that the symmetry is the same because the right-hand side is still x squared. So we're going to pick x values in our little table the same as we did in the standard parabola. And we'll see the symmetry appearing here again. So if x is -2, 2y is -2 squared, which is 4. So y is 2. When x is -1, 2y is -1 squared, which is 1, and so y is 1/2. When x is 0, 2y is 0, so y is also 0. When x is 1, 2y is 1 squared, which is 1, so y is 1/2. And when x is 2, y is 2. We'll plot these points. Notice the difference between this and the standard parabola. Is the scale and the y-axis. So the standard parabola looked like this. Where this is 1, 2, 3, and 4. So for instance, this point here in the standard parabola case is 1, 1, whereas here it's 1/2. So the difference is we divide all of these numbers basically by 2. Here we're multiplying y by 2, but to adjust the axis we want to divide by 2. You might want to try to graph these on something like Desmos. You can just put these equations in and you'll see that what happens is if you graph them right on top of each other is that the graph of our new transformed parabola is compressed by a factor 2. Now we're going to look briefly, this isn't really in the realm of what we're talking about in this course, but I do want to discuss it since we're doing these in parallel. What happens if we multiply the y here by 2 and we get this equation for our transformed circle? Notice that that's the same as this, but we won't look at it that way. What we have is the same thing. The scale on the y-axis is now changed. So now the distance between the origin and this top point of the circle is now r over 2 instead of r, which is what it was on the standard circle. So this is actually going to be a compressed circle, which is called an ellipse. Graph these on Desmos. Looking at this example, you might want to think about this independently, but now the scale is changed by multiplying the old scale by 2. And so now this is a parabola that is stretched by comparison to the standard parabola by a factor of 2. Looking at this example, plotting points, we'll plot the same points because the symmetry is the same. So when x is -2, for instance, negative y is 4. And so y is -4. Let's pick 0, 0. If x is 1, negative y is 1, so y is -1. We plot these points. We find out this is a reflection of our parabola. It's a downward facing parabola. So whenever you have a negative sign in front of the y, you're going to get a downward facing parabola. If you do a similar transformation from the standard circle, there is no change. You might want to think about why. Just plug it in and see. Okay, let's graph this equation as an example. This is a parabola because the y part is not squared. The vertex is where this is 0 equals 0, so that happens at -2, 2. We're going to compare it to our standard parabola. We see that it is compressed. It's a downward facing parabola. So let's look at this for the moment, and we see that it's a downward facing parabola, and the y-axis has this adjustment of a division by 3. So for instance, this point here, which on the standard parabola was 1, -1, or 1, 1, it is now 1, -1/3. Now we can transform the equation by subtracting 2 from the y and adding 2 to the x in the equation -3y equals x squared. Which means the new vertex is at -2, 2. And otherwise is the same shape as that. We get this parabola. It opens downward because of the negative sign and is compressed because of the factor 3 in front of the y, -2. Try to graph this. Identify the vertex. First check, so try to graph this. First note the adjustment of the scale of the y-axis. Note the vertex, and that will help you graph. Okay, let's look at these examples. These are somewhat different. This isn't in the form remotely similar to the standard parabola or anything that we've graphed so far. We know how to graph things that look like this if A, K, and H are given. So our goal right now is to put it in that form. So the y's are on the left-hand side, the x's are on the right-hand side, so that'll be our first step. Put the y's on the left-hand side, the x's on the right-hand side. Now we recall the idea of completing the square. So to do that, we notice that we need a -2 here. But if we do that, we also need a 4 and a -4. Now this is equal to this. And then we add the 4 to both sides to get that. So now this is in a form that's something that we know how to graph. We can identify the vertex as 2, -2. And it is not, the y scale is not compressed. These marks are 1, 2, 3, and so on. So I'm not going to write them there to clutter the picture. So now we would consider the circle. This is also in an unfamiliar form. So we're going to use the idea of completing the square again. So we collect the x's, we collect the y's, so that's just a rearrangement of the terms. We complete the square, so we identify the 2, we add and subtract 4, so that x squared plus 4x plus 4 is equal to x plus 2 squared. We do the same thing for the y, identify the -3, add and subtract 9. Note that y squared minus 6y plus 9 is equal to y minus 3 squared. And finally, we add the -9 and the -7 to get -16. We'll add 16 to both sides to get this equation. We identify r to be the square root of 16, which is 4. The vertex is what makes the left-hand side 0, which is -2, 3. We can find 4 points on the circle by adding 4 to the x-coordinate of the center, subtracting 4 from the x-coordinate, subtracting 4 from the y-coordinate, adding 4 to the y-coordinate of the center. We get those points. We try to form a circle that passes through those 4 points. Those are guiding points to help us graph. Okay, try these 2 problems. So some problems in the assignment, you will need the midpoint formula, and you'll also need the distance formula. I discussed the distance formula earlier. Here is the midpoint formula. Suppose you have 2 points, x1, y1, and x2, y2. The midpoint is the point that is on the line connecting them and is exactly in the middle, so that the distances between each point and the midpoint is the same. Okay, that's called the midpoint. So what are the coordinates of the midpoint? It is not difficult to see that you just average the x-coordinates to get the x-coordinate of the midpoint, and you average the y-coordinates of the endpoints to get the y-coordinate of the midpoint.